Good afternoon, guys. Welcome to my YouTube channel. I'm here lecturing you modern programming languages. Today, this afternoon, we'll go on with our NumPy modules, Python NumPy. So far, we have completed 4 lessons, and today, this afternoon, we'll go on with lesson 5. And without wasting any time, I'd like to start up our development environment. Okay, lesson 5 and our demo 5 is 53. Here, once again, we import NumPy module as MP. MP stands for the short form for NumPy, and it facilitates in order to write each time this NumPy name. And here I define a NumPy array. So as to include 9 members, 1, 2, 3, 3, 4, 5, and 4, 5, 6. And our purpose here to calculate mean of this array. So at first, I'd like to print out the original form. Okay, just this is the title. I'd like to use this method, and after leaving an empty line, after applying mean function, the result will be seen like this. And here, okay, in my development environment, at this pane, I can see the current situation of our variables, our assigned variables. And here we can see the calculation. Here, the average value, the mean value of this array, in fact, 3.666. And just I'd like to be sure about that. Okay, still going on. And how about the next example? Here, we'd like to calculate standard deviation of an array. So our array is simple, includes 4 members. So we would like to calculate standard deviation of these numbers. Just by mentioning these array members, we can recall std method, and let's run it right away. Okay, there is no explanation, just it calculates so as to be 1.11, and as you cannot see here, we didn't assign any variable, so you cannot see here, just it's a hint what we are using. Okay, this time we'd like to calculate variance of an array, and as you can remember, variance is the mean value of abstract value of x minus x dot mean to the power of 2. That's to say, standard deviation is the square root of variance. In fact, this stands for the variance, and in the next example, we'll see that. Okay, our array includes 4 members once again. So by means of this var method, recalling this var, we can calculate easily, okay, like this. Okay, 1.25. The variance of this array is 1.25. And how about the next example? Here, our array includes 3, 1, 2, and at first I'd like to print out the original form, and after that I'd like to apply argument sort to this x. Our array is called as x, and y variable will be our sorted x array, and after that I'd like to print out, and I'd like to reconstruct original array in sorted manner, in sorted order. Once again, this time just I use this format, so that does it. And I'd like to reconstruct original array by using a loop. This is another method, just as a remind for it. I mentioned this, and let's make it run and see. Okay, just let's go one by one. Our array is the original form is 3, 1, 2. Okay, x is indicated here, as you see, three members, and after leaving an empty line, I apply argument sort method, and after that I assigned this to our variable y. So argument or sort according to x, it can be seen here 1, 2, 0. That means if we translate it, one means this is the first one. This is going to be the first one. Okay, this is 2, 0, 1, 2. This is going to be the second one, and 3. It is going to be the third one. Okay. The index value of this one is 0. Okay, 0 is indicated here. It's understandable, I think. And reconstruct original array in sorted order. I just mentioned this format, and after that reconstruct in by using it for I in Y. This loop does it. In fact, just look here. I will paraphrase it once again. We would like to sort this array. Okay, in original form, this is like this. But after we sort it, it's gonna be 1, 2, 3. Okay. So what are the indexes of 1 and 2 and 3? Okay, this 0, 1, 2. Okay, 1. Okay. This is going to be the second one, 2, okay, and 3 will be the last one. So what's the index number of 3? Okay, 0. Okay, 0 will be replaced here. Okay, just reconstruct original array in sorted order. Okay, this is the original array 1, 2, 3 after we sort it. Okay, and reconstruct the original array by using loop. Okay, just since we use this print structure and with comma, it's going to be printed in separate lines 1, 2, 3, such as 1, 2, 3. Okay, I think it's clear enough. Let's go with another example. I here define an array so as to include some numbers, including zeros. And what's our purpose here? What's our main aim here? To print out without zero elements, or other saying, just we'd like to eliminate the zero ones. So at first we print out the original form. Okay, original array. Let me print this one, run this one. Okay, here we must see the a variable. Okay, like this. The original one, nothing is changed here, and in fact it's 3 times 3 matrix. And after applying non-zero function, that means we are eliminating zero elements. So just I'd like to print out this one. Okay, just 0. It gives in fact indexes. Okay, just see that 0, comma 0. Okay, this is the first element. 0, comma 1. This is the second. Okay, and there is no 0, comma 2 because it's 0, so it's skipped. It's omitted. And instead, we repeat for the row 1. Okay, 1, comma 0 is not used. Okay, just look here. 1, comma 0 is not exist. So 1, comma 1 exists because 20 is a non-zero element in fact, and 1, comma 2 actually 10 is a non-zero element as well, and How about the second row? 2 comma 0. Okay, 2 comma 0 will exist because 50 is non-zero, and 2 comma 1 will be skipped. Okay, that doesn't exist. And 2 comma 2, okay, 2 comma 2, or other saying, the coordinate of this 0 1 2 0 1 2 0 1 2, okay, 2 comma 2 stands for 60, will be shown here. And how about the next one? I'd like to show you how to make arithmetic operations by using relational operators. This is the purpose of this program snippet. And here I define an X array so as to include 9 elements, 9 float elements, starting from 0 up to 8. And by calling reshape method, I would like to reshape it so as to be a 3 times 3 matrix. And in this form, I would like to print out our array, or our original array is. And after that, here I print out a title declaration here. Indices of element greater than 3. So this is the magic word here, where x greater than 3. So the condition that's going to be seek during the calculation is like this. So I'd like to print out the array y, and I'd like to do another thing here. Use these indices to get elements satisfying the condition, and I'd like to print out the indices one by one. So just let me run this one. Okay, our original array starts from 0 point. As I said, it's floating, and without including 9, because it's up to 8. That means 9 elements, including 0. And this is the condition that to be looked for. Okay, which elements are greater than 3? In fact, just we can see not there doesn't exist in this row. So starting from here, but not including 3. In fact, 4, 5, 6, 7, 8. In fact, okay. Just by saying this, what's the coordinate of this guy? 0 1 1 to 1. Okay, 1 corresponding to 1. Okay, that meets our condition. How about the next one? 1 2 2. Okay, that stands for this one. Just to paraphrase once again, you guys, 0 1 2. Okay, the number, the order of rows like this: 0 1 2. And how about the columns? 0 1 2, like this. And if we mention the coordinate, or the index of this element, you guys, 0 1 1 comma 2, we would like to say. Okay, 1 comma 2. And how about this one? 2 comma 0, 2 comma 0, and 2 comma 1, and 2 comma 2. Okay, 0 1 2 just stands for this, 0 1 2. And at the last, by means of the last print command, just we'd like to print out the index of these members. Actually, 4 5 6 7 8 will be printed out like this. Okay, this is the indexes. Actually, the values of members, in fact. But this notation stands for index, you guys. And here I define define a condition. We're going on conditions by calculating giving conditions, some conditions. And here I don't want to repeat once again. Here our condition in fact is a name of a variable, in fact condition variable. Okay, modulo x comma 2 equals to or evaluated as a 0. That means you guys we are looking for even numbers, even members, in fact, because if there is no remaining value as a result of a modular mod operation, that means we have found an even number. And here, element-wise value of condition title is printed out here. And just we mentioned condition without giving any quotations. Just simply we're using brackets. Okay. Brackets. Okay, extract elements using condition. So, for example, we asked to be print out the extracted elements, and extract keyword is run here, condition comma x. So just when we run this, okay, this is the original one. Okay, as you see. How about this one? Yes, this is the original one. Okay, element-wise value of condition. So we're searching even ones. So just have a look here. 0 is in definition is an even number, and 2 is even also, 4 is even, 6 even, and 8 is even. So just true, false, true, false, true, false, true, false, true. Structure must be created. Okay, true, false, true. Okay, false, true, false. Okay, and true, false, true. The false expression here stands for that the number here is an odd number, not even number. That's another saying. It does not meet this circumstance, these conditions. Okay, and, that's why such a truth table will be created as a result of this condition. Okay, just we'd like to extract the elements that meet this condition, which are the even numbers starting from 0 up to 8, including 8. And how about the next example? Here I arrange an array once again, starting from 0 up to 8, up to 6, sorry. And I'd like to print out the original form like this. And let me run this one in order to show the current values of our variables. Okay, this one, and that one, and our original array is 0, 1, 2, 3, 4, 5. Okay, and just applying ID function, just IDE, that means 0, 1, 2, 3, 4, 5. And B is assigned here as A. So after printing B, there's something wrong here. Just anyway, just I'd like to skip this one. There is an error here. In fact, just ignore it. Okay, view or shallow copy. I'd like to show you an example of view command. Just My machine is under heavy duty operation. That's why it's going to take a little bit time to get the result after we run the interpreter. Okay, just here I reshape my array so as to be 3 rows and 2 columns. Okay, uh, 3 rows. Let me run this once again. Okay, 3 rows and 2 columns. Okay, I reshape it, and here create a view of A. I would like to view it. Actually, nothing is done here. Just we made it clear to view much to see it much easily. Okay, view, and ID for both the arrays are different. Different. In fact, one of the ID of the first one. Okay, and the other this one. So by showing this example, just I'd like to show that when we store our arrays, even if they are the same, they occupy different memory places in the memory, in fact. So that indicates that this numeric value that corresponds to the specific relevant ID of that array is different from each other. That means that's translated as that their occupation place or their memory location are different from the other. So how about the last one? I'd like to change its shape. So b dot shape 2 comma 3. I would like to change it so as to 2 rows and 3 columns, and this one the shape of A, this is the original one, will be printed out like this. And how about the last one here? Okay, just here I'd like to give an example of slicing, array slicing. Okay, our array includes 6 members. Okay, it's printed like this. This one. And here I create a slice here. I indicate it as by s semicolon comma semicolon 2. That means that's gonna trace all of them and start with the index 2 and to print out this. Okay, just as you can see, first one, our array 10 10, 2, 3, 4, 5, and after slicing, we will include all of them because in trivial manner it chooses all of them and starting 0 up to index 2. That means we will select all of them, in fact. Okay, that means like this, and to create another column slice. So just I here make a change here. So instead of including index 2, just I slice it at the index 1. So just we're taking we'll get just the first one. Okay, 10, just as you can see here. Sorry, this one, and this one will include 10 to 4. Okay, create another slice. This time I will start index 1 and I will finish at index 2, but not including 2. And I'll choose all of the columns, and let me show this. Just we're talking about a row because we placed our descriptive selection criteria for row, in fact. and all columns will be selected. That means 2 and 3. That stands for this column. Okay, will be these columns, this one and this one, will be printed. And just for the paraphrasing this, 1 semicolon 2, that means 0, 1, 2. This and this range will be searched. However, the upper limit will not be included. That means only 2 and 3 members will be printed out. Okay, that's the end of lesson 5, you guys. I know some of you might find it useless. However, this NumPy module just meets the needs of engineers and statisticians and scientific researchers, and that not necessarily be satisfying one for the whole stuff. That's the case. I'm doing my best to paraphrase the specifications of NumPy, and it's up to you which one is useful for you, and which one you can learn it by heart. That's okay. Thanks for your watching, and thanks for your time, you guys. We'll go on with our NumPy modules and their utilities that have provided us. And please keep following me. And bye bye for now. Hoşça kalın. Bye bye.